Hello, today's video is going to be covering identifying metals in the machine shop. I have an assortment of different metals here in front of me that we're going to try to identify using the means that we have available in the machine shop. So there's many different types of metals that we'll find throughout the shop, and we have examples here of several different types to identify. So in the beginning, cast iron was the first metal of choice. All right, so this is an example of a cast iron pot here. All right, so cast iron was mined from the earth as iron ore and heated in a furnace to create a metal. All right, and that metal was used for castings and ultimately was refined to create steel. All right, and these are the types of steel that you see a blacksmith use. This was a wrought type of steel. All right, the common element of both cast iron and wrought steel is that it's a ferrous metal. All right, and by a ferrous metal, I mean it contains iron. All right, if you recall the periodic table of elements, the identifier for iron is Fe, and that's where the term ferrous material comes from. All right, an iron containing, or a material containing iron is considered to be a ferrous material. So throughout the history of manufacturing, metals were refined, all right, steels were created, and different alloys. All right, so that's how we end up with such a variety of different metals that we need to identify. So the quickest way to identify a ferrous material is to look for rust. All right, this is an iron pot that was used to boil some water, so it shows signs of rust. So we're going to use that as one of our means of identifying the metals. All right, the second way to identify metals, all right, is to separate your wrought irons and bar stocks from your castings. All right, this is an example of an aluminum casting here. All right, this is an example of a forged iron or steel connecting rod. All right, so these materials and their specific alloys are identified a little bit different than our bar stock and our wrought materials. All right, so we're going to separate the castings from the bar stock materials, and we're going to focus on our bar stock and see how we can go about identifying that. All right, so we're looking at ferrous versus non-ferrous. All right, the presence of rust would indicate a ferrous material. All right, a non-ferrous material might be an example of aluminum. All right, aluminum, you're not going to find any signs of rust on it. All right, another non-ferrous material is brass and bronze. All right, no rust present on those. All right, so the second identifier is going to be the color code. All right, so materials, when it comes from the steel mill, it's generally color coded. All right, you'll see this yellow on the end of this bar. All right, some red spray paint on the end of this bar. All right, this is a blue and a white color code. It actually indicates an alloy. All right, so the material will be color coded. The problem with the color codes is that it's not a universal system. All right, so if you're familiar with the color codes from the steel manufacturers that you're using or the material suppliers you're using, you can sort the material in your shop by color code. Right? But it may not be the same if you use a different supplier. So be careful with the color codes. They are a good indication if you have a number of different bars of the same material that it is the same. So the next level of identification might be a color code, as this green indicates, and then a marked identification of the alloy of this bar. All right, so this bar is 4140 material, and it's been marked the length of the bar as 4140, so that as it's used, the mark doesn't get cut off it and discarded. Okay, we're going to mark the full length of material. Some shops will paint a stripe down the material also in the color code, all right, the full length. So it's useful in helping to keep the materials from getting mixed up. All right, another marking here. This is a D2, is a type of tool steel. So in this case here, the 4-number code is not on it, but it's the type of steel. All right, so D2 is a commercial identification for tool steel, for an air hardening tool steel. So this would be an indication of a remnant piece, a piece that's been cut off of a bar and it's been labeled so that it doesn't get mixed up. All right, it's important to keep track of the type of steel if you're going to use it for a project that involves heat treating. All right, so we don't want to lose track of what type of material it is. All right, some of the non-ferrous materials, aluminum for example, it'll have a laser marked identification on the bar itself. All right, so down the length of the bar material, it might be the alloy and the material type. All right, so that information may already be on the bar. So that's another method of marking the material and identifying material from the steel rack that's been marked. All right, so if we're separating out our castings and our forgings and we're color coding our bars, all right, we've got our alloy numbers marked on this bar, so we're in pretty good shape. We can identify these materials based on that. All right, now here I have an example of 3 similar materials. All right, 3 bars, all look very similar. All right, so there's one more method that we can use to identify these in the shop. All right, so visually I can look at it and I can see that this one is exhibiting a little bit of rust. All right, whereas this one exhibits no rust at all. All right, and this one here appears to have no rust at all. All right, now this one is noticeably lighter. All right, so I'm going to classify this one as an aluminum alloy. All right, whereas these two here are steel. All right, now I can verify that with a magnet. All right, because ferrous materials are magnetic. All right, we can stick to a piece of iron, stick to a piece of steel. All right, it does not stick to a piece of aluminum. So I can verify this one here. It's light, it's non-magnetic, it must be aluminum. All right, I can check this one. This one is magnetic, it's got some weight to it, it's showing some signs of rust, so it's a ferrous steel. All right, this one here weighs about the same as the steel, shows no indication of rust, it's also non-magnetic. All right, so this is a stainless steel. All right, stainless steel is non-magnetic. It does not contain iron, so it does not rust, but it is heavier than aluminum, so it's we can identify it by the weight. All right, so 3 similar materials. We can use the means that we have on hand to classify those so that we don't get them mixed up in our use. All right, the last thing I wanted to look at is some materials after they've been processed will have an indicator laser marked onto it or inscribed. All right, this is a tool bit and it's marked cobalt. So the type of steel is labeled right on it so that we know what to properly use that for. All right, this is a tool blank also, and it's marked with a H2 and a marking down in here. All right, so we know this is ready to be used, can be sharpened and used as a cutting tool. All right, so that's a couple of indications of tools that have been materials that have been pre-marked, and also some of the methods that we use in the machine shop to classify our materials and to prevent materials from being mixed up. Now here's a material here. This is also a stainless steel. All right, I can verify it by the fact that it's non-magnetic. All right, it shows no exhibits of rust. All right, and I know that this particular steel, stainless steel, is very specific because this is a part used for spacecraft. All right, so in this case, we would need much further proof of what this material's origin is. All right, so what we've gone over here is just basics to separate materials in the shop and to give a quick overlook of how the materials look. But the true origin of a material can be very important to its end user. So there is paperwork and a traceability to materials. All right, so when that is the case, then there should be a paperwork and some indication of where that material is sourced from and what exactly the material is. All right, so thank you for joining me in today's video. I hope that it was beneficial for identifying materials in the machine shop. Thanks.